How are you, my friends? This video is presenting 8 old exams questions related to combining functions and composition. This is about lecture 33 of the algebra course. Now, question number 1, we have two functions, h of x, x minus 4 under the square root, and k of x is equal square root of 7 minus x. We need the domain of the division h of x divided by k of x. Domain, as you know, is the intersection between the two domains. So we take the domain of the first one, square root of x minus 4, will be the radicand greater than or equal to 0. So x greater than or equal to 4. The square root of 7 minus x, the domain we take 7 minus x greater than or equal to 0, x will be less than or equal to 7. If you find the intersection, it will be 4 to 7 closed. You see both closed, but remember that x cannot be 7 because we are dividing the function h by k. So that's why we make at 7 open, because it is in the denominator here and we cannot accept any 0 there. Question number 2, we have a function capital F of x is equal 4th root of x plus 9. Find two functions f and g such that f circle g will be the capital F. Easy. So we know f circle g is f of g of x. So try to think of a function g. If you replace it inside the f, you will get the capital F. So I can take here g of x as x plus 9, the inside part, and this function small f is 4th root of x. Now find f circle g, just replace g inside the f. You will get 4th root of x plus 9. Question number 3, we have a function f of x 2x plus 4 and function g of x ax plus b. Given the composition, f circle g of x is equal to 10 minus x. Find a to the power b, which means we have to find a, we have to find b, then we make a to the power b. Remember, the composition now is given, and we have two variables here, a and b, in the function g. So what I'm going to do is, this is given f circle g, 10 minus x. Let's find f circle g from the two functions f and g. So f of g by definition here. So I take g of x, which is ax plus b, replace it in the x there. So it becomes 2 in the bracket, ax plus b plus 4 in the function f there. Multiply that, 2ax plus 2b plus 4. Now, this is f circle g, and this is f circle g. So I have two of them. So I say compare both composite functions. So when you compare them, minus 1 here is the coefficient of the x, and here the coefficient of the x is 2a. So they are equal. And also the constant here is 10. See the constant without x, and here the constant is 2b plus 4. So 2b plus 4 is equal 10, so we get b3. And 2a is equal minus 1. This is coefficient of the x, coefficient of the x. Little tricky. So a is minus half and b is 3. So a minus half to the power 3 minus 1 over 8 is the answer. This one I said not easy. Given the function g of x, 1 minus x cubed. F is not given here, see? F is not given. We need f of 2 if g circle f is equal to 1 minus 2x minus x squared. Only the g is given, 1 minus x cubed. We need f of 2. Now, what do we do? Let's find first g circle f of 2. See, g circle f of 2, it means g of f of 2. So f of 2, I replace it in the g there. See, it's 1 minus f of 2 cubed. All right? Now, I have also given here G circle f of x, which is, I can find also G of f of 2 from this function here, decomposition itself. So 1 minus 2, and then this is 2, and this is 2 squared. So 1 minus 4 minus 4, so that's minus 7. So now these are equal, you see? Because both are G circle f of 2, G circle f of 2. So 1 minus f of 2 cubed is equal minus 7. Rearrange it. This becomes f of 2 all cubed is equal 8. Take the cube root of both sides. We need f of 2. The answer is 2. Just a little tricky question. This one is a normal, nice question. Given the function f of x, x over x plus 1, we need the domain of f circle f. Usually we find the domain of f circle g, g circle f. We need f circle f. Now, the idea for the domain here is to find the function f circle f. So we replace f in f. See, all this x over x plus 1, I put it in the f, in the x up and down. See, it becomes a complex fraction. See, x over x plus 1, x over x plus 1 plus 1. Again, I will replace all the function f again in f. So when you simplify this, you get x over 2x plus 1 after you simplify all this complex fraction. Now, the domain of f by itself is r except minus 1. So all real numbers except minus 1. And we need the domain of f circle f here is minus all real numbers except minus half. Then I have to find the intersection between this and this. Because domain of f circle f, the final domain is the intersection between domain of f and the domain of f circle f. So when you draw the intersection, you get minus infinity to minus 1 to minus half, union minus half to infinity. Here is simple question, normal standard. F of x is x squared minus 20. G of x is equal to square root of 10 minus x. Let's find all these images. F plus g of 6, f circle g of 1, f times g of minus 6. Just replace 6 in the function f with g here because we have addition. Here first we go 1 in the g, whatever the number we put it in f again. So that's easy. Just go slowly please here and apply the sum. You see this is the sum, this is the composition, and this is the product. It's so straightforward. Simplify all these, check the numbers, and you will get 7 over 64. I hope you can get the answer. It's not that difficult at all, just some calculation. This one we have a function f of x, x minus 1 over 3 minus x. Then we have a g of x, square root of x plus 2. Let's find the domain of f circle g. Now here we have two different functions. See, we have to find f circle g first, and then find its domain. But remember, g is the first function we use, so we have to find the domain of g. Now let's look at question number 7 solution. We have the function f and g, and I will look first at the domain of g because it's easy. I put it here on the side. Take the radicand x plus 2 greater than or equal to 0. So the domain of g only from minus 2 closed until infinity. Now let's look at the important part here. F circle g means f of g. So I replace all the g square root of x plus 2 inside the x in the function f. So it becomes like this. Now, we already took care of the x plus 2 in the radicand here, in the radical, finished. Now this one, 3 minus square root of x plus 2. This one, in the denominator cannot be 0. See, the denominator cannot be 0. So we have to solve for x. Then take 3 on the other side, square it. You get x plus 2 is equal to 9. So x cannot be 7. Let me just show you, check here. Put 7 there. 7 plus 2, 9. Square root of 9, 3. So 3 minus 3, 0. That's why we say x cannot be 7. Now, the domain will be the intersection of this and this. So from -2 to infinity, and we have to remove the 7. So the domain of F circle G, final domain will be closed -2 to 7 open, union 7 open to infinity. Now here we have a nice question where we have f of x square root of 16 minus x squared, not a linear, this is quadratic or polynomial. G of x will be square root of x squared minus 1. Let's find the domain of the product f times g. As we have mentioned before, we have to find each domain, then find the intersection. So we take function f, square root of 16 minus x squared, take the radicand, 4 minus x, 4 plus x is greater than or equal to 0, make a table of signs, 4 minus x, 4 plus x, choose a number there, let's say minus 10, remember? So this is plus and minus. Here you choose 0, plus and plus. Here you choose, let's say 50. Then when you multiply, you get minus, plus, and minus. So solution 1 will be, which is the domain now, of this function f. Solution 1 means the domain of this f. So it will be from -4 to 4. Now, solution 2 of this inequality here. Now, x squared minus 1, x minus 1, x plus 1. The 0 is 1 minus 1. Make a table. So this is minus and minus. This is minus and plus. If you take 0 there, when you multiply, you get minus infinity to minus 1 closed. See, all closed now. Union 1 closed to infinity. Solution 2 is the solution of this inequality, which is the same as the domain of G. And the solution 1, solution of this inequality, which is the domain of the F. Now let's find the intersection. See, this one, I start solution to minus infinity to minus 1. Union 1 to infinity, all closed, except at infinity for sure. This is -4 to 4. When you find the intersection, so domain of f times g will be closed -4 to -1 closed, union closed 1 to 4 closed. Now, these are the answers that we have seen in the 8 questions. If you want to see more examples about this lecture 33, combining function, please you can visit the Algebra Course Lecture 33 itself. Thank you guys for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you very much.